As the Army transforms to meet the challenges of an ever-changing global environment, we are creating new ways to deploy more powerful and more advanced forces into different areas of operation. The operating environment of the future will likely cover all aspects of full-spectrum operations. The Army's cumbersome, decades-old maintenance system had a larger-than-necessary logistics footprint. Its successor, the two-level maintenance system, offers the more efficient, rapid maintenance response required by our modern forces. The Army's new maintenance system offers many advantages, including a reduced logistics footprint in the battle space, faster returns of equipment to the fight, elimination of most maintenance evacuation requirements, increased productivity of maintainers, and therefore increased system and unit readiness. In the 20th century, the Army fought and maintained its equipment in ways that are not applicable today. Operationally, conflicts in the last millennia were linear. When the Army took ground, an undefeated enemy was always forward, never behind. Today's global threat environment is smaller and asymmetric. Current U.S. defense policy is primarily focused on countering terrorism and insurgencies. Because our future deployments will likely take us into unsecured areas, the Army will be required to conduct day-to-day missions from small operating bases. The new threat environment has also changed how the Army maintains its equipment. Back in the 20th century, the Army fought and won wars by advancing toward a geographic objective. When we gained a piece of enemy ground, we established a massive presence that included huge maintenance storage and repair sites and specialized repair facilities. Because of the Army's long, slow-moving logistical tail, winning the war meant positioning spare parts and repair facilities close to the front. This way of maintaining equipment in the field is now obsolete. This is because parts and even entire components can be rapidly shipped into the battlefield, often hours after they are requisitioned. The changed nature of global threats also makes it impractical to position a large general support maintenance facility in a combat zone. In current and future full-spectrum operations, combat zones will likely be nonlinear. This means that all forward operating bases, including large maintenance support elements, must be adequately secured. Today, the Army does not need to shift as many support personnel to perform force protection missions. Today's technology enables us to design and build weapon systems with modular components that can be rapidly replaced. Onboard sensors and diagnostics promptly alert soldiers and equipment operators that a component is about to fail. The proliferation of electronic monitoring systems means a reduced footprint is required to identify and replace faulty components, modules, and assemblies. Army regulations for the care and maintenance of Army vehicles were originally published in 1939. This four-level maintenance system, with its echelons of operators and crews, organizational level maintenance personnel, direct support level maintenance personnel, general support level maintenance personnel, and depots were well suited to a large self-supporting Army moving en masse toward an identifiable objective. The structure of the Army's maintenance system was predicated on how long it took to make a needed repair. The longer the repair time, the farther back along the maintenance support chain that the broken equipment was evacuated. Because it often took several days to transport equipment from a rear area repair facility to the battlefield, the Army stockpiled huge quantities of repair parts in forward areas. The two-level maintenance system effectively consolidates the four echelons of the old system: organizational level maintenance, direct support maintenance, general support maintenance, and depot level maintenance, and fold them into just two levels: field maintenance and sustainment maintenance. With the two-level process, field maintenance includes system maintenance using line replaceable units or LRUs, battle damage assessment, repair and recovery or BDAR, adjustments, alignments, fault diagnosis, scheduled services, condition-based maintenance, and preventive maintenance checks or PMC is referred to as on or near system maintenance. The intent of field maintenance is to return the system back to the user as quickly as possible. Sustainment maintenance, the repair of individual system components to one standard in order to provide a consistent and measurable level of reliability, is referred to as off-system maintenance and can be performed anywhere in the integrated logistics chain. The intent of sustainment maintenance is to repair subcomponents and return them to the supply system for usage by whomever needs it. Today, when soldiers in a forward area find a fault on a component of a system, The non-functioning component is swapped with a fresh replacement if it cannot be rapidly repaired, adjusted, or serviced on or near the system, and repaired later at a sustainment maintenance facility. These procedures will be defined by new policies that are still in development. Implementing the two-level maintenance process will require fundamental changes across the Army. Doctrine and technical manuals are being rewritten. Organizations are transforming. Training will be conducted differently. New materials will be developed and fielded. New facilities are being created. Military occupational specialties will be consolidated. And most importantly, Army leadership will be required to regard the equipment maintenance process in an entirely new way. The two-level maintenance system streamlines the process of maintaining Army equipment. This streamlined process offers several advantages. It eliminates redundancy in paperwork. It consolidates maintenance capabilities, eliminates the passing of equipment through multiple echelons to be repaired, and instead enables units to repair as far forward as possible. It reduces the overall steps required in equipment maintenance, and it speeds the turnaround time to get equipment back to the user by eliminating the administrative bureaucracy between multiple echelons and empowering organizations to repair their organic equipment. Another great advantage for commanders from the two-level maintenance process is the reduced size of the logistical footprint. Within a theater, the Army no longer disperses multiple multi-echelon maintenance units that possess overlapping capabilities. The simplified steps of the two-level maintenance system continues to allow time for soldiers in the field to apply quality checks that confirm the complete restoration of the operational status of a faulted piece of equipment. In addition to ensuring maintenance is performed in a quality manner, the system ensures that the chain of command remains fully informed about the operational status of all equipment. The two-level maintenance process reduces the need to evacuate equipment from forward areas to the UMCP and then to the BSA for DS-level maintenance support. This saves the time, money, and manpower previously needed to perform these evacuations. Scaling back evacuations removes logistical soldiers from harm's way. This also frees recovery vehicles to perform on-site recoveries in heavy lift as they were intended. Under the Army's old maintenance system, much of a soldier's time was spent inspecting equipment and validating faults. The new two-level system requires only 3 inspections: an initial inspection to confirm the fault, an in-process inspection for quality control, and a final inspection. The new two-level maintenance system also significantly eliminates paperwork and electronic reporting procedures. Under the old system, soldiers were required to update as many as 48 different records and forms, many of which were embedded in 4 separate computer systems. This means that the two-level maintenance system has a single database. Lastly, the new system offers ground commanders the advantage of giving them closer control of the unit's operating budget. The two-level maintenance system significantly reduces the time that passes from the moment a piece of equipment ceases to be mission capable to the time when it is returned to service. The two-level maintenance system offers many advantages, including streamlined troubleshooting processes, elimination of redundancy in paperwork, faster turnaround of inoperative equipment, shorter retrograde times, elimination of most evacuation requirements, reduced demands on battlefield personnel for the validation of faults and the evacuation of inoperative equipment, reduced movement on the battlefield, exploits expected improvements in the reliability of embedded diagnostics and prognostics, reduced logistical footprint on the battlefield, and closer control of the command's operating budget. The two-level maintenance system is key to the transformation of Army maintenance in support of our future operations. The system embraces next-generation technology and personnel capabilities. The two-level maintenance system is a force multiplier. It frees commanders to fight and win.